who can we draw our inspiration from? What is the reasonable life cycle of a building? What does WLC means? These are the three topics that we'll touch right now. Basically, I want to mention an American visionary, Buckminster Fuller. Buckminster Fuller was the person in the 1950s who thought of Earth as a spaceship, and who started to think about and proposing that we should kind of check out all the elements, all the resources that we have available, and taking them in account to use them wisely. A little bit what the commission later on did, the German commission later on did on the 1987. Among his projects, besides the creation of the geodesic invention and creation of geodesic domes, Buckminster Fuller had this kind of ideas. He thought of New York City, right there in Manhattan, being able to be covered with a huge dome. An environmental dome that would protect New York and its air, quality of air. Those were the kind of ideas that Buckminster Fuller had. So among those things, he actually also proposed to calculate the carrying capacity and to work towards it. Now, this is our inspiration, and I do invite you to read about Buckminster Fuller later on. Actually, on the Sandbox, you will find a couple of articles on his projects, and a website dedicated by an institute that he used to lead. Now, let's go to the second point, which is the stages in the building life cycle. We've been accustomed to think of buildings as something that either we create or the blueprints are given to us as contractors. And what we do actually is we have a terrain, and then we just go ahead and do the takeoff, and then create the building right here. And after we create the building and buy all the materials, combine and put them all together, and then the building is done. And then we have a keys, and then we have some owners, and then we get our money, and end of the story. But basically, things have this linear conception of a building from nothing to a profit, and then we don't care about is being changed. And it's being changed because we can't think of the building in those terms anymore. Because buildings keep on existing, and they came from somewhere and go somewhere else. This means that now buildings have to be thought as in a lifetime cycle. Right here, we have extraction of raw materials. Where does the sand come from? Where does the oil come from? How are the glasses going to be made? In all of these extraction, we have to check if those things comply with our principles that we've been talking about. Are they being done in a region where there's sustainability? Is the ecological footprint too strong? Is it not? Is it the appropriate one? Well, once we have looked into that, we go to the second stage of the building, which is what we do, the production of the building components. That means how they are manufactured. What amount of energy does it take to put together the wood, to put together a knob, to put together a window, a closet, all parts. And again, do those parts comply with the policy that we've been talking about with the last three factors? Is the carrying capacity being threatened, or is it is it something that it's a project that is sustainable? Is it something that we can actually perform without harming the earth or not? Once we have that, we actually build something. It's the construction phase. And the construction phase is what we are very, very, very familiarized with, and I'm not going to refer too much to it because it's something that you will learn during the next years if you're right here in the in construction management or something similar. But then it used to end up over here. So we used to have a cycle. But now things have changed. Now we have to think of how the building is being repaired, maintained, or replaced. And what happens afterwards? What happens with the demolition? What happens when the building is demolished? Where do those parts go? What happens? Can we recycle them? Can we reuse them? That's the new policy. Recycle, reuse. That's what we have to be thinking of when we're putting together a project. And then at the end, how is this going to come back and become again a raw material? So it's not a linear construction as we saw before. It's a cycle recycle construction. And I'm going to put an example right here. A few years ago, I was given a project in Ecuador. We had to build a small community for people that lived in the rainforest. Yes, people live in the rainforest. So what we did at the beginning is we went with the community, put them all together, worked with them, gave them some resources. Actually, we planted the trees. Waited 4 years. When the trees were actually grown up, because over there things just grow exuberant and magnificent, we then used appropriate building techniques just to lumber everything and put everything and dry the wood accordingly, so it would, cut it on the best season. That means when there's full moon, so that the liquids, the savila stays inside the tree. And then we actually did the construction process. The community was involved. People actually helped, and we put together houses that with a lifespan calculated for 50 years. Now, thinking that in a place and time, humidity, animals would come and eat it. And then all that was actually harvest from the earth returns back to earth, and the impact on the project is very low. That is what we have to think. Now, that's Ecuador. That's over there, rainforest. Today, we have to look, especially if we live in first world, and I mean United States, Europe, we have to think in a new concept. We have to think of the whole life costing. That means that we have to examine the building in 3 stages, and I'm going to put them over here for you. I hope you see them. They will be posted on the drawing. The cycle is this one. One is a stage of design, in which the costs are very high, and then the building part, in which we will add a new sets of all kinds of gadgets and all kinds of facilities to minimize the use of energy and maximize the performance of the building. And then we have to think of the lifespan of the building and its use. So when we make a building, we have to think not only in terms of that cycle that I mentioned before, but also what's going to be the lifespan from the design to its use. A technique, this is the whole life costing, is a technique for examining and determining all the costs in money terms, direct and indirect, of designing, building, a facility management of a building through its entire service life, including the disposal cost. Think of a public building. Think of a library. Think of a school. We only think doing it and building it and leaving it right there. What about the electrical cost? What about the water sewage system? What about all the energy consumption in AC and air conditioning and the other services that we need to keep the atmosphere clean inside the building? What happens with all of that? Well, those are social costs. Those are taxes that we have to pay. But if we go to the local authorities now and say, okay, I got up this building proposal that is from inception to completion, from the design to the use, this building is going to be lasting for 60 years, and this is what's going to happen in this building. Now think of the cost in a long term. Will a government or a city or a region want to buy a building that is cheap on the design, an expensive building, but has a heavy burden on the maintenance? They won't. So we got to change that.